Well, hello students, welcome back to Mathematics Application class with me, Mr. Alfie. This video is about review for test 4 about statistics. Let's check this video out. The table shows the masses of the school bag of 50 students. As you can see, it means the total number is 50, the frequency. A. Find the range of the data. You know, the formula for the range of the data is maximum number subtracted with the minimum number. As you can see, the maximum value of x is 8 and the minimum value is 2. So the range is 8 minus 2 equal to 6. For the set of data, this is the set of data as you can see. Find the lower quartile or Q1, median or Q2, and upper quartile of Q3. As I thought in the video before, Q1 is divide the data in two parts equally. This is Q2. And then Q1 is divide the first half of data equally. And Q3 divide the second half of the data equally. So this is Q1, Q2, and Q3. Q2 is obviously 59 as you can see here, but for the value of Q1 and Q3, Q1 is between 28 and 34. It means you need to find the average between 28 and 34. You add those numbers together and divide it by 2, you will get 31. And so with Q3, you find Q3 in average of 73 and 83, you add this number together and divide by 2, you'll get 78. And then for the same set of data, find the interquartile range of the data. As we have found before, Q1 equal to 31 and Q3 equal to 78. So the interquartile range is Q3 minus Q1 equal to 78 minus 31. So the IQR or the interquartile range is 47. And then let's move on to standard deviation. Find the standard deviation of the data 1, 2, 3, 4, and 5. As you can see, the data is ungrouped. So the first thing that we need to identify is how many data are in here. So the data is only 5. There are 5 numbers here. And then we're going to find the sigma of x. Sigma of x is total of all these numbers, all the data. So 1 plus 2 plus 3 plus 4 plus 5 equal to 15. Next, we need to find the sigma of x squared. So the total of square of each data equal to 55. And then the formula for standard deviation for ungrouped data is square root of sigma x squared per n subtracted by square of sigma x per n. We have found every single number in this formula. It's 55 per 5 minus 15 per 5 square. We know that 55 per 5 is equal to 11 and 15 divide 5 is 3 and 3 square is 9. So 11 minus 9 equal to square root of 2. This is standard deviation for this data. And then still standard deviation, but find the standard deviation of the data below. The data served in a table. It means the data in a group. So we're gonna use the formula for standard deviation for grouped data. Remember, the first step to solve a standard deviation in group data, we need to add 3 more columns. The columns are the column for fx, and then the column for x squared, and the last one is the column of fx squared. So fx, how can we get these numbers? These numbers comes from f times x. So for this number 0, it comes from 0 times 5. The x is 0 and the x is 5. So 0 times 5 equal to 0. And this number comes from 6 times 20. 6 is the f and 20 is the x. And so this number, and this number, f times x. And then this number is x squared. You just need to square each and every single numbers in this column. 25 comes from 5 squared, 400 comes from 20 square, and so on, 40 square, 60 square, and 80 square, and you will get these numbers. And then these numbers comes from f times x square. This is the f, this is the x square. So 0, it comes from 0 times 25. 2400 come from 6 times 400. 14,400 comes from 9 times 1,600. And these numbers come from 10 times 3,600, and 32,000 comes from 5 times 6,400. This is come from f times x square. Okay, and then we need to find some sigma. First, sigma of f is a total of f. You add all these numbers together, you will get 30. Sigma of x square, you find the total of all these numbers in this column, you will get 1,480. And then sigma of f x square is from this column. You add these numbers together, you will get 84,800. Remember, the formula for standard deviation for group data is, this is the formula. So square root of sigma fx square per sigma f subtracted by square of sigma fx per sigma f. Standard deviation equal to, we have found all the numbers that we need. It's 84,800 per 30 subtracted with square root of 1,480 per 30. We make the numbers in the same denominator, it's 9, and we'll get the standard deviation equal to square root of 3,536 per 9. This is box and whisker plot looks like. This is the whisker, it's the minimum value and the maximum value, and then the box, it's represent Q1, Q2 or the median, and Q3. Remember, each part is actually 25% from the minimum for to Q1, from Q1 to Q2, and so on and so on. So for Q1 is actually 25% of the data. For Q2 is 50% of the data, because Q2 is the median. Divide the data in 2 equally. And Q3 is actually 75% of the data. Then we combine arithmetic means will be x1 bar n1 plus x2 bar n2, the whole divided by n1 plus n2. If there was a third division of class 5C, we could have x3 bar and n3 also. Now, let's jump to the next example. Average of 10 male students is 72 and 15 female students is 80. Determine the average of the whole class. This is the formula of combined average. X bar is combined average, and 1 x bar 1 for the male students, and 2 x bar 2 for the female students. So, we know that the number of male students is 10, and the average of male students is 72. The number of female student is 15, and the average of female student is 80. So the x bar equal to 10 times 72 equal to 720 plus 15 times 80, 1200 per 25. 10 plus 15 equal to 76.8. This is the combined average of the whole class.